It seems that our models for the development of the primordial cosmos are losing credibility. The James Webb Space Telescope has revealed mysterious structures dating back to the early days of the universe, structures that, theoretically, should not exist in such forms. However, the cosmos doesn't appear to be concerned with the theoretical models we have developed. The telescope has already identified 6 mysterious galaxies that appear too large and massive for their era of origin, just a few 100 million years after the Big Bang. Recently, Webb discovered a new enigma at the heart of a galaxy that existed when the universe was only 770 million years old. The telescope identified a colossal black hole with a mass exceeding 1 billion solar masses. Experts have yet to explain how such a gravitational monster could exist so early in the universe's history. Some researchers speculate that this black hole might be a remnant of a previous universe, suggesting that the Big Bang, the prevailing theory of the cosmos's origin, might need re-evaluation. In fact, an increasing number of scientists propose that the universe was not born in a single event, but exists in a continuous cycle of expansion and contraction, with periods of cosmic birth and death. According to current cosmological theories, the primordial universe should have been a place of small galaxies composed of only a few elements. Models suggested that the first galaxies would be small and modest, but Webb's observations have challenged these predictions. The telescope has identified galaxies that, despite being very young, already had masses equivalent to hundreds of billions of solar masses. Some of these galaxies date back to just 500–700 million years after the Big Bang, yet they were already extraordinarily massive. This contradicts the prediction that, early on, the universe didn't contain enough matter to form galaxies of such sizes. The discovery has left astronomers baffled, as it challenges the laws of galaxy formation as we know them. Specifically, Webb observed 6 galaxies, whose light has taken over 13 billion years to reach us. These galaxies appear far more massive than our cosmological theories can explain. Their mass might even exceed that of much more mature galaxies, contradicting models that suggested galaxies grew gradually over time. Scientists now ask how these galaxies formed and grew so quickly. One proposed explanation is that the density of matter in the primordial universe was 2 to 5 times higher than predicted by our models. Another possibility is that galaxies developed in ways we do not yet fully understand, perhaps by gathering matter from external sources or through galactic merger mechanisms that we have not considered. Whatever the answer, it is clear that we must revisit our ideas about early galaxy evolution. Another major mystery concerns supermassive black holes. Until recently, it was thought that these massive objects at the centers of galaxies developed gradually, accumulating matter through their powerful gravity. This matter formed accretion disks that fed the black hole itself, giving rise to one of the most powerful forms of energy in the universe: quasars. Quasars are among the brightest and most powerful objects we can observe, with their luminosity coming from the radiation emitted by matter falling into the black hole, which is heated and accelerated until it becomes extremely bright. However, despite predictions, astronomers have found numerous quasars in the primordial universe with black holes that already seem enormous, up to 10 billion solar masses. According to traditional models, it would be unthinkable for these black holes to have formed so quickly, as they should have taken billions of years to accumulate their mass. The question we now face is, how could these supermassive black holes have appeared so early? Could there be another mechanism that fueled their growth much more efficiently than we thought? To answer this question, scientists are closely studying the structure of a distant quasar called J120+0641. Webb has provided incredibly detailed observations of this quasar, revealing a supermassive black hole that existed when the universe was only 770 million years old. The images show that the quasar is fueled similarly to modern ones, yet with a structure surprisingly similar to more recent quasars. This suggests that, despite its youth, the black hole was already well developed. This is another indication that events did not unfold as expected, raising new questions about the nature and evolution of black holes. Moreover, Webb detected that the observed quasar not only has an enormous mass, but also appears very normal in its characteristics. Despite its young age, the accretion disk and dust torus surrounding it resemble those seen in modern quasars, further challenging existing theories. The biggest surprise is that these colossal objects seem to have been fully formed, contrary to the idea that black hole growth requires much longer periods. The discovery that supermassive black holes were already fully developed, just a few 100 million years after the Big Bang, forces us to reconsider our understanding of cosmic evolution. It might be that these objects had a very different beginning than we imagined, and that there are processes we still do not understand, such as primordial accretion of matter much more rapidly and efficiently than what we observe today. These discoveries also challenge the Big Bang theory itself. According to the current theory, the cosmos originated from an infinitely dense singularity about 13.8 billion years ago. But if the structures we observe in the primordial universe are already so complex and advanced, it could mean the Big Bang was not the absolute beginning. Some scientists suggest the universe might exist in a continuous cycle of expansions and contractions, a process known as the Big Bounce. In this model, the universe is not born in a single event, but expands and collapses repeatedly in an infinite cycle. In other words, what we perceive as the birth of our universe could merely be a transitional moment within a broader cosmic cycle. Modern theories, in fact, do not fully explain the singularity of the Big Bang, and quantum mechanics conflicts with the idea of infinite density. Alternative models, such as the Big Bounce, suggest the universe might have always existed in various forms, transitioning through cycles of life and death. Nico Poplavsky, a theoretical physicist at the University of New Haven, proposes another fascinating theory, that the universe might have been born inside a black hole. In this scenario, what we consider the beginning of the universe would actually be the explosion of a cosmic seed located at the center of a pre-existing black hole. If true, this theory would radically change our understanding of the cosmos and its origins. Thank you for watching. Leave a like, subscribe to the channel, and activate the notification bell so you won't miss upcoming videos.